In this lesson, we are going to construct parallel lines. Now, let's define what that means, what parallel lines are. They are lines, and they have to be on the same plane that do not intersect. Why am I saying this on the same plane part? Because imagine this pencil here represents a line that is shooting through space. I could have one line shooting through space over here, and then I could have another line that is sticking up out of the page, and it is shooting upward. This line is shooting this way, this line is shooting this way. These lines will never intersect with each other. They are moving in different directions. They will never intersect each other, but they're not parallel because they're not on the same plane. In order for lines to be parallel, they have to be sitting on the same plane. If I had lines that looked like this, and just this much of it was drawn, I would say these lines, because I'm saying they're lines, they're not line segments, they're lines, they go on forever. These lines would keep going and then they would intersect over here. So these lines are not parallel, but these lines are parallel because they would keep traveling and traveling and traveling and never intersect. We're going to actually use a construction technique from earlier, copying angles, in order to do our parallel line construction. This is really just copying an angle. So let's say you had a line and you wanted to construct a parallel line that goes through this point. So there's another line that passes through that point and is parallel to this first one, but I want to figure out exactly where it is. Is it here? Is it there? Is it this? Like, where exactly is it? And the way I'm going to do that is to add some features into the picture. I'm going to send another line segment through this point and through this line. It doesn't matter what angle you put it at. I could make it like this. I could make it like this. I could make it over here. I'm just going to sketch some line segment in. And now that this line segment is here, an angle has been formed. And in order to make a parallel line, I'm going to take this angle and I'm going to copy it and I'm going to put it right here. Because if this angle and this angle are the same, like if this angle and this angle are the same, I just want to slide that angle up here and then I'll have my parallel line. It will look like that. So the way I'm going to do that is, let's write out steps and then I'll do it over here. We start with a line, we start with a point. Step one is we add some random segment. It doesn't matter what angle you put this segment at as long as it passes through the point. Step two is we start doing our angle copying process. So we center the compass here, we open up by some distance, and we make a random arc. And the purpose of making this random arc is to put into the picture an imagined triangle. There's now an imagined triangle here where this side and this side are the same. And I'm going to just copy this triangle and put it up here. So I opened up by some distance, I put an arc. I'm not going to change anything. I'm going to take this exact same arc and put it right here. This arc, I'm going to move up here and I'm going to make the exact same arc. This side matches with this side. This side matches with a side that's right here, but I don't know exactly where it is. Is it that? Is it that? Is it that? In order to find out exactly where it is, I'm going to measure this imagined invisible It's not drawn in. If you want to draw it in, you could draw it in, but this distance from this point to this point, I'm going to reset my compass to be this distance, center myself here, move up to this point, and put an arc. And when I put that arc, I will have copied this distance. And by copying this distance, I get this intersection point, which I can connect through, and I will have copied. So I went 3, this one was 4, this is 5, and now this angle and this angle are the same. And there's a name for these. When you have an angle that's like in the top right and the top right, they are called corresponding angles. Corresponding kind of means matching. And corresponding angles are congruent when lines are parallel and cut by this thing, which is called a transversal. Corresponding angles, they're matching, they're in the same place, the top right, the top right. If you have parallel lines that are being cut by a transversal, then the corresponding angles are congruent. There's a symbol we could put in this picture. It looks like this, a little arrow and a little arrow, and this arrow both pointing in the same direction. This means parallel. This means that these two line segments or lines are parallel to each other. So let's do this construction. We start with some line. We have some point. I'll put it right there. I want to first create an angle so that I can then copy it. So I could make any angle I want. I could make something that's close to a 90-degree angle. I could make something that's very shallow. I could make something, let's go about here. There's an angle here now. I want to copy that angle and put it over here so that this vertex is sitting at that point. So I go to this vertex and I make any random arc that I like. So this was my step 1, this was my step 2. There's a triangle. I can visualize a triangle in this picture now. There's a distance from here to here. This distance, I'm going to copy it and put it here. This distance, I'm going to copy it and put it here, but I don't know exactly where it goes, and so I make the arc fairly big. That was step 3. Then this distance needs to get measured so that I can copy it and put it here. So I center myself at that point. I'm going to open up. That looks good. Put a little arc here to measure. Yep, that's the right length. So now I'm going to take this distance, and I'm going to put it here. This goes over here. That was step 4. And now that I have this intersection point, I have copied my imagined triangle. This side got copied to right here. This side got copied to right here. And this side got copied to right here. But I don't need to draw a triangle in because the purpose was not to construct a triangle or copy a triangle. The purpose was to copy that angle. And by copying that angle, I have made parallel lines. And when you do a construction's a real physical thing that should be physically correct. Like whatever we said, corresponding angles are congruent when these parallel lines are cut by a transversal. So these corresponding angles better be congruent. I can measure them and check. So I center my protractor here, 0 degrees, 10, 20, 30, 40, 50, 65. Happen to have drawn a 65-degree angle. Then I come over here and I check that same angle to make sure it has the same measure. 0, 10, 20, 30, 40, 50, 65. Yes, both angles are about 65 degrees. So this was a good construction.